Hi guys. So today we're going to start with chapter number 14, which is sources of energy for you guys. Okay. Uh, so first things first, let us look at what does it mean. What is a good source of energy? I mean, I like all of you understand why we are looking at this, right? Because a source of energy is what helps us do any work. Correct? Any work that we do is because of a source of energy. Like we walk because of muscular energy. Okay. Now, let us first think of what are the sources of energy that we use. Okay, when we go to school, just before going to school, like the two main things that we do when we're going to school is we eat our breakfast and then we go to school. Correct? So, to eat breakfast, that is to cook, right? We use a stove wherein we use heat energy from the stove, and we use food, right, which has chemical energy inside it, right. And then we either walk to school where we use muscular energy, right, in our muscles, which we get from the food that we eat, correct, or we take the bus, which works because of chemical energy, okay, because of reactions and the engine and all, which is there inside the bus, okay, which works because of chemical energy, and mechanical energy because the wheels move, correct, and it takes us from the home to school or from any place to any other place. Let's look at cooking, okay, in a little bit more detail. So how do we like the three of the main ways in which we cook. The main thing in cooking is what we want to heat the food inside a vessel, correct. So to heat the food, we burn three things, right. We burn one of the three things. We burn either wood, okay, where we have these wooden pieces which are assembled together, and we put it on fire and we keep the you know uh, the bowl on top of it, the vessel on top of it, okay. Or we use oil. This is an oil stuff, okay, where we pour the oil through this hole, and then we have this there is a tiny wick over here, like a cotton thread, okay, which we will put on fire. We will light it on fire, and then the fire will come from here, and we will put the vessel on top of this. Or we use gas, like inside this cylinder there is gas, okay, inside this it is connected to the stove. From here we will switch it on and we will get fire, and we will put the vessel on top of that and we will heat it, okay. So what are the, like, how do we choose what we use, correct? How do we choose whether we use a gas stove or an oil stove or a wood stove? How do we choose that? We choose depending on where we stay. Supposing we stay in a village, then we use either we use, if we have a lot of wooden pieces around, then we use a wood stove. Or if we have the gas connection, then we use a gas stove. Or if we have oil, then we use the oil stove, okay. So depending on where we stay, like in cities and all, we will generally use the gas stove, or what is available. So if there are wood pieces, then we use the wood stove, correct. Okay, so what are the characteristics of a good energy source? Okay, the first thing that we have to look at is the amount of heat produced when it is burnt, okay, whether it is enough amount of heat or not, correct. We have to look at whether it is enough amount of heat or not. And amount of smoke produced while burning. If there is a lot of smoke produced while it is burning, then it might not be comfortable for us to work with it, correct. The availability, whether the energy source is easily available or not, whether it is easy to store and transport. So if it is easy to store and transport, then we can the availability will be a little bit more, correct. Like from the village, if we can take wood pieces up, bring it up to the city, then wood stoves can be used even in the city. So how available is it? Ease of store and transport, okay, like because of this, if it is easy to store and transport, the availability also increases. And whether it is affordable means, can we buy it? Is it possible for us to pay money for? Is that much money, do we have that much money with us that we can pay for the source of energy. Okay, so these are the main 5 characteristics of a good energy source. Alright, so what are they? Amount of heat produced when burnt, amount of smoke produced when burning, availability of the good energy source, ease of transport and store, and whether it is affordable. Okay. Okay. Now moving on to conventional sources of energy. What does the word conventional mean? Conventional means old. Okay, conventional means old. So what are we looking at here? Old sources of energy. Okay, what were the old sources of energy? Already we saw wood, right? So wood was the oldest source of energy, and from wood we came to coal. Okay, coal is this thing. Can you see in this image over here? The person is holding coal. Okay, that is coal. Now coal led to industrial revolution. That is, in factories and all we use coal. Okay, so coal is the reason for industrial revolution and factories. Now can you see this factory over here from which a lot of smoke is going? That is because coal is being burnt inside the factory. Okay, coal is a fossil fuel. Petrol and coal both are fossil fuels. What are fossil fuels? Okay, what are fossils? So very long ago, okay, what happened is the living organisms, they died. Okay, like very long ago they died, and they decayed and fell into the mud. Okay, and then what happened is after many years, and after a lot of because of a lot of pressure and a lot of other issues, a lot of other things that happened during the up until now, that is, I'm talking billions of years ago. Okay, very long ago, what happened is the bones, okay, the bones of the living creatures and the flesh of the living creatures and all that turned into fossils. So fossil is basically that. What is fossil? Very old remains of a living creature which lived very long ago. Okay, old, very old living creature. When it died, it went to the earth. Okay, it died, and the body fell into the earth, and it decomposed, which is, it started insects started coming and eating it and all that, and then under a lot of pressure it becomes fossil. Okay, when we use these fossil fuels are like petroleum, coal and all. So these fossil fuels are what is the most what is being used now. Okay, a lot of them are being used, like we hear petrol car, diesel car and all. No, that is from this only. Okay, from fossil fuels. So what is the biggest problem with fossil fuels is that when we burn it, can you see all the smoke that it is releasing? That is a lot of smoke. So it leads to air pollution. Air pollution in turn, so all this smoke in the air, okay, will lead to acid rain. Acid rain is very bad. Okay, if it rains, acid rain, that means it is going to come, and if it falls on plants and all, the plants will all die. Okay, and it leads to, so this is all these fumes which are this smoke which is being emitted, which is coming out of the factory. Emission of oxides of carbon, nitrogen and sulfur. So in 9th grade we learnt all this, right? It leads to, fossil fuels lead to air pollution, lead to acid rain, it leads to emission of oxides of carbon, nitrogen and sulfur. And we don't like oxides of carbon, nitrogen and sulfur because if they are there in the air, okay, when it rains the next time, if there is a lot of it in the air, when it rains the next time, it will cause acid rain, and because of that, all our plants and all our, if it falls, acid rain falls on us, we will have skin issues and all that. Okay, like skin scars and all that. How can we reduce pollution? Because we're using fossil fuels a lot, right? We can't just say that we don't want to use fossil fuels anymore. So how do we reduce the pollution? It can be reduced if efficiency is increased. What is efficiency? That is the amount of energy that we are getting from a particular burning. If we are burning, like say a bucket of fossil fuel, the amount of energy that we are getting, if we can increase the amount of energy that we are getting, that means we are increasing the efficiency. And what we'll do is these oxides of carbon, nitrogen and sulfur, oxides of carbon, nitrogen and sulfur which is being emitted, we will reduce the escape of these harmful gases. Okay, what we'll do is we will contain these harmful gases, and we will probably, like, we if we reduce it, then these harmful gases will not be there in the air. So lesser acid rain. Now if efficiency increases, what will happen? That means, see, like, maybe before we could use one bucket of fossil fuel to, say, only run one house. If we can increase the efficiency so that one bucket of fossil fuel means running two houses, that means what? We have to reduce, we are almost reducing the amount of fossil fuels that we're burning by half, correct? So since we are reducing the fossil fuel burn by half, that means we are able to actually, like, save a lot of fossil fuels and not, lead to a lot of air pollution. Okay, so it can be reduced, it cannot be stopped. Okay, now we'll watch a small video, okay, in which one of the exercises, one of the activities in your textbook is being played, is happening, like we can see it. From after that, we will come back to this slide and we will move forward. Okay, so in this video, what we are going to do is one of the activities in your textbook. So here is a tennis ball, okay, and in this tennis ball we will now make slits, okay, we will make holes, and we will fit metallic fins, that is metallic plates basically. Okay, so basically what we're trying to do is, have you seen a fan? In a fan you see all these, what do you say, sides, right? I mean, like this, it looks like a fan, right? So we're trying to create a fan only. Okay, and then we're going to attach it to this particular stand so that if we blow air from here, it rotates freely. Okay, now what else are we going to do? We're going to attach a dynamo, okay, which is going to convert this rotation. Now remember, in magnetism we learnt about an electric generator, correct? In the electric generator, what was happening? The rotation of that rectangular coil, we use that to create current, right? We use that to create current. So here also that is what we are doing. What we are doing is we're going to try and use the rotation of this tennis ball with the metallic plates. Okay, we're going to attach it to a dynamo which is attached to a bulb, so that we can see, okay, if we push air and if we make this rotate, then the bulb will glow. Okay, that is the basic principle of these sources of energy, okay, these kind of sources of energy, like what we are going to see from now onwards. The main thing is this turbine. So this setup is called a turbine. Okay, this rotating thing, this rotating fan, or like this rotating tennis ball, okay, here it is a tennis ball, correct? This rotating tennis ball is the main reason for how we will create the electricity. So let us see what happens. From this cooker, okay, in this cooker there is water, okay, and the water is going to create steam. So you can see where the whistle goes in a cooker, we have put this pipe. Okay, this pipe is going to blow the steam into this tennis ball, and it is going to start rotating. So see, once it starts rotating, the dynamo is converting this rotation into electricity. Can you see that? The rotation is being converted into electricity. Okay, so like we saw in the video, okay, the tennis ball and the metallic plates, that is what a turbine is. So the simplest turbines, what do they have? They have one moving part, which is your rotor blade assembly. That is basically your rotor blade assembly is your tennis ball with your metallic plates, and you have a moving fluid. Okay, moving fluid, in this case what was the moving fluid? The steam that we took from the cooker via the pipe and we put it onto the rotating tennis ball. That is your moving fluid. Okay, it spins, and that spinning is taken by the dynamo and converted into electricity, similar to an electric generator. So what are we doing? We're converting the mechanical energy to electrical energy. This is the main way in which we generate electricity. Okay, we always almost always have a simple turbine which will be rotated, okay, by some steam or some gas, whatever it is that we are going to use. And that rotation, which is a mechanical, thing, right? The rotation is a mechanical action. That mechanical energy is then converted into electrical energy. Okay, now let us look at conventional sources of energy. Let's come back to conventional sources of energy. What are a few of the conventional sources of energy? These are the four ones, okay? Like, we will watch videos to understand them better. So the first one is a thermal power plant. Then we have a hydro power plant. We use biomass, or we use wind energy. Okay, let's look into each of them in detail. So in this video, we will be looking at a thermal power plant, okay, and how it works. The main just basics is enough for you guys, okay? You don't have to go into a lot of detail. So just like listen intently, because it's really cool how the power plant works, okay? So we're going to look at a thermal power plant. So let's first read what is written. Yeah, a thermal power plant converts the chemical energy stored in fossil fuels into electrical energy. So the main thing, okay, now let's first look at the word thermal power plant, right? What does thermal mean? It means to heat. It means heat, okay? It basically just means heat. So in this case, what do? We take the chemical energy which is stored in the fossil fuels and we convert it into electrical energy. How do we convert it into electrical? How do we take the chemical energy is the most important thing in this particular process. Okay, so let's look at it in a little bit more detail. Alright, so what is falling? These black rocks which are falling, okay, those are coal. That's coal, basically your fossil fuel, okay? And then it falls and it's going to be made into very, very small pieces, okay, so that it burns much faster. So see, it's being made, it's basically being grinded. And then it also this smoke that you can see, that is basically steam, which is hot air which is being blown into them to remove any amount of water in them, okay? And then it goes into this area. What happens over here? Here you can see the fire. It's called a boiler. So the fire, basically, that's where the coal will burn. Okay, the coal is going to burn. Okay, so how do we take the chemical energy and what are we doing? We're burning it. So basically we're converting the chemical energy. This is how we're taking the chemical energy. Okay, and we're converting it into fire. Okay, into heat energy. So we're taking the chemical energy and we're converting it into heat energy. What do we get from fire? It's hot, which is why it's called a thermal power plant. Okay, so after burning the coal, okay, do you see this pipe over here which is in this inverted S shape? So in this pipe, what we do is we take water. Okay, water is being sent into this pipe. So because of this heat, right, the pipe gets hot and the water inside the hot pipe, okay, becomes steam. Okay, so this steam is then, so see, as you can see, the water is coming and then it gets converted into steam, okay, and it goes outside. This pipe then goes into this particular turbine. Remember the turbine, the tennis ball turbine? So these are also turbines. Okay, the steam is then comes into this turbine and it makes the turbine move. It makes the turbine rotate. Okay, like the tennis ball rotated, it makes the turbine rotate. As you can see, this is the turbine. It makes the turbine rotate, and that rotation, okay, is sent. This is basically a shaft. A shaft means the rotation is like the shaft will also rotate with the rotation. Okay, with the turbine rotation. And it goes into the generator, right? Remember the generator, like how we had learned the electric generator and magnetism, the same thing. Like in that we were using a rectangular coil and magnets to create the rotation motion. Here we are using the steam to create the rotation motion. The generator converts the rotation. So as you can see, the shaft is also rotating. Okay, the generator converts the rotation into electricity. Okay, and that electricity is then sent out, this is called a transformer. So the transformer converts the electricity from the generator and is attached to your, see these electric lines, right, which give you electricity at home. This is how it is connected to the electric lines, and this is how we get electricity at our homes. So as you can see, the electricity is going from the generator to the transformer. The transformer makes it usable at home, okay, so that we can send the electricity through these power lines, and it is sending it through the power line to our homes. So this is how a thermal power plant works. So now we're going to look at hydroelectricity. Okay, so what is hydroelectricity? Alright, so next we're going to look at hydroelectricity. Okay, what is hydroelectricity? So as you all know, like, okay, what we already know what electricity is, correct? But what is hydro? Hydro basically means water, correct? So now in this case, back then in the like before, we saw how we got electricity out of fossil fuels. Now let's see how to get electricity out of water. Okay, so hydroelectricity is basically what we do. The main thing that we do is we use moving water, we convert moving water into electricity, and it is renewable. Why? Because of the sun. We will forever keep getting moving. We'll forever have moving water, right? There will be no there'll always be, okay, moving water. The main thing again over there, like how we already discussed, there is a turbine and there is a generator. Okay, so how do we use? So the main thing in a turbine is what? We know that the turbine should rotate, and the generator will convert this rotation into electrical energy. So here we're using flowing water to rotate the turbine. Okay, so here you go. The moving water is passed through the turbine, and the movement is what causes the turbine to rotate. All right, so that is what we do. There are two ways in which this can happen. So let's look at them one by one. We have the dam or the runoff river. These are the two ways in which water can be converted into electricity. Okay, like moving water, movement of the water. Basically, we're taking the kinetic energy of the water, right? Remember, kinetic energy, movement of anything is kinetic energy. So kinetic energy of water, and we're converting it into electrical energy. Basically, we take the kinetic energy of the water, and then we rotate the turbine, okay, and that gets converted into electricity by the generator. So let's go one by one. Let's look at the dam first. So you have there you go. So you have the turbine, the generator, and the transformer, which gives us the electricity to the main, those poles. Remember the electricity poles, like those, okay, into those it connects it. So that's how it goes. All right, so this is how a dam looks. Okay, now what is a dam? In a dam, what we basically do is we create this particular, we basically obstruct water. Okay, we collect water. Like in this case, what we're doing is, in this dam, okay, we're collecting the water here. All right, and this water, remember how when we put something on top, it leads to it collects. If you're not doing any work, that means if supposing I've kept a ball on top of a table, right, then the ball has potential energy, and the minute the ball falls off the table, the potential energy gets converted into kinetic energy. Remember this? So the same process, the same thinking is what we're going to use here. In a dam, we will store the water at a higher level, okay, at a higher level, and this water's potential energy, okay, will get converted into kinetic energy when we open the gate. So there will be a gate here. When we open the gate, the water starts to flow through this, correct, because there is a level difference. Because of, you know, level difference, the water starts to flow, and this flow of the water is used to turn the turbine. All right, the turning of the turbine is then used by, like, the turning is then used by the generator to generate electricity, and then it is sent into the main line. So here the potential energy of the water gets converted into kinetic energy, okay, and it settles over here. So that is the main way in which we have it, okay. So the a reservoir is the same as a dam. All right, so like no confusions, don't worry. There's a higher reservoir from which water flows, makes the turbine rotate, okay, which leads to electricity, and there is a lower reservoir here. So in the previous, like just before this, we saw how it works in a dam, correct? Now we're going to look at how it works in a run of a river. So basically, what is the run of a river is, we use the river's path. Okay, we use the river's flow, like from the mountain top, the river flows down, right? This flowing down motion is what we use to rotate the turbine. Okay, over there we created the height difference, so that the water flow can lead to turbine rotation, right? We had the higher reservoir, and we had the lower, end, where we opened the gate and we created the kind of, water flow basically that we see in our rivers. Okay, so here what we do is we create a tiny pathway where the same process, we attach a turbine here, and this turbine is what we use to create the electricity.